Hi, I'm Ryan Nickel, CTO at DSA Ocean, and today we're going to talk about how you can go through a comparison of motion-affected comfort from a sensitivity study on the vertical center of gravity of the ship. So this is a really interesting parameter you can explore in the early design stage that can really give you a lot of information and guidance on what the implications are for motion-affected comfort on ships like large yachts. However, there's a couple things to be careful about when you're going through this process and calculating it, and that's what I wanted to highlight. So when you look at the project files for a Shipmo 3D project, we'll look at the 50-meter generic yacht here. You'll see at the top here, there's ship dimensions and loading condition. The height of the CG above the baseline is a project level parameter. As a result of that, it shows up in all of the different parameters and applications you're using in the ProteusDS Ship Motion 3D toolset, rad, diff, build chip, all that stuff. And it's there on purpose to make sure that you know exactly which file you're looking at. It's really easy to get confused when you're looking at a whole bunch of different ship model parameters, and you don't want to get these mixed up. So for any of these fundamental parameters, for example, height of CG by baseline or trim or whatever, I really recommend what you do if you want to do a sensitivity study on that is just copy the project folder and then let's copy and paste it somewhere else. So I made another folder over here. I'm going to call this one under my projects folder here 50 meter. We'll call it VCG1, and I'm going to make yet another copy of this. We'll call it VCG2. So what I'm going to do is go through this and set one with a vertical center of gravity that's 10% lower, and then one that's 10% higher than nominal, and just kind of demonstrate like what that looks like when you go through the comfort assessment, and also get a sense of like what a realistic variation of that could be from the motion RAOs that are derived from that. So first, we'll open up the first project. I do also suggest you go through it one at a time because the software is going to remember the last folder that you opened up, and it can get really confusing if you start trying to do things one at a time. So what I'm going to do is I'm actually just going to exclude all of this stuff. So we're just starting from a blank slate. This is VCG1. We're going to change this to 2.7, so that's 10% lower than the nominal value for that 50-meter generic generic yacht. And we'll go to add existing data. Now you want to be really sure you're looking at that VCG1 and opening up the input files for that. And you'll need to change this value. Again, be really careful with the file paths. Look at the deck half of the hull. We'll run that. Go to the panel lid, VCG1. Height of the CG above baseline, 2.7. Really make sure we're looking at the same one here. Sure, that's going to be just fine. Rad diff, same thing, 2.7. Make sure we're looking at all the right ones. Now, this rad diff calculation will take a few minutes, so what I'm going to do is just get it to run. Now I'll set up the other one. So while I'm going through the process of setting up VCG2, now this is going to have a higher center of gravity by 10%. Okay, let's just exclude everything to start the project over from the beginning. So this is going to be 3.3. So everything else being the same, with a higher center of gravity, we should have a lower metacentric height. So this is going to reduce stability but increase comfort, generally speaking, because it's not as stiff in its restoring motion and roll. So on the other hand, the one with a lower center of gravity is going to have everything else again being equal. It's going to have a higher metacentric height, so it's going to be really stiff and roll. And we're going to see how that affects things when we look at the motion affected comfort. So we'll go through this. We're looking at VCG2 now. Change this to 3.3. Make sure we're looking at the right folders here. Three point three. Rad diff 3.3. Okay, same deal with rad diff. It's going to take a few minutes to run here. So we've got them both running, and we'll check on them in a few minutes to see how things have gone. Okay, those radiation and diffraction calculations are done on both of them. You should see something pretty similar for both of them, as well as on the nominal VCG one. Everything looks pretty good there. So we need to continue for both of these to finish up the ship model. So let's just make sure that we are looking at, okay, this one is VCG2, so we will keep working with this one. We'll go add build ship, VCG2, and we got to make sure that we have the right radiation and diffraction database calculated for that. And we'll run the, oh dear. I forgot, see, this is what I was talking about. This is height of CG above baseline. I forgot to change this to the new value. For VCG2, we're doing 10% above, so we'll go 3.3 there, and we should be able, so what it's doing is it's catching that the radiation and diffraction database has a different value here, 3.3, and it's calling out that, hey, there's a difference here, you got to watch out. So that's a good thing. So now we run it, and everything is good. We'll go to Seakeep regular. This is for the seakeeping analysis in regular waves, for which we calculate the RAO from, and here we have the 3.3 adjusted VCG value, just making sure we're consistent across all the files. And we've got enough information here for calculating the ISO comfort rating. We export the motion RAO values. That should just take a second. Okay, so we'll have the same, the thing is we're going to have the same named file, so I'm going to recommend we rename those files in a second, just so we keep track of them. Now we're over to VCG1. This is with the lower VCG, and we will go through and do the same thing. So we'll go to build ship. Now see, this one has saved our old file location to VCG2, so you got to be really careful. You switch over to VCG1 here. And remember, this one's got to also go down. We're doing the lower VCG for VCG1 here, 10% lower. So you can kind of see if we're flip-flopping back and forth between projects, the file path thing can really mess you up, so we don't want to do that. So we'll finish running build ship here, and we'll do Seakeep regular for this one as well. And the height of CG is 10% lower than nominal, VCG1. And we've got our sort of default parameters here. Export the database file. Okay, so later you may find it handy to have a couple of these RAO files around so you can switch quickly and do different comfort assessments. And what you can do, just for example, why don't we just make a little folder on our desktop here, 50 meter RAO files. So I'm just going to call this one VCG1, copy it into this folder, and then we'll go to VCG2. Copy it in there, and then where is the original Generic Yacht 50 meter, here we go. So we'll just leave this, we'll just call it bare hull. We don't have any appendages or anything like that on there. Okay, so now what you can do is we're going to go to the Ship Motion toolbox now, and I'm going to do I want to keep the same positions for the areas, 50 meter RAO files. And what we'll do is we'll go to bare hull. So this is the sort of vanilla nominal VCG location. I'm not going to change the areas here at all. Leave everything else the same. Yeah, 50 meter yacht, bare hull. And we'll run the comfort analysis. And then we'll put this over here. You can see there's our nominal comfort rating here and the areas, individual areas and so on. Now what we're going to do is call this one VCG1 minus 10% nominal, and we'll load the VCG1 value. So the notes are helping differentiate what's different about it. We'll run the comfort rating. So again, lower VCG, higher metacentric height, we should have a lower comfort rating. And lo and behold, we do by quite a bit. It's 29% overall instead of 44 for the nominal. So on the other hand, we should also see a difference when we look at VCG2 where we go plus 10% nominal. So we'll load the other motion RAO database here. And we'll run the comfort assessment. And so we see a huge improvement in comfort as well. So I know it's a lot of numbers we have in front of us here. Kind of what I wanted to draw attention to is sort of the difference between, you know, the really high VCG value, low metacentric height, we have a really high comfort value, and then the lower VCG value, okay, so higher metacentric height, it's more stiff. And in particular, it's going to be more stiff in roll. So you see individual values for the areas. Now, if you look down into the data, you have the criterion here, and then there's two parameters you can look at individually, the motion sickness values and the EGA. So EGA is effective gravity angle. It's kind of like tilt in a little way. So you know, we don't really see too much change in the motion sickness, but when we look at the effective gravity angle, there's quite a big difference. There's a lot that are not passing in the higher metacentric height. This is what you'd expect. You'd expect it to be more stiff in response, and we see a lot of the places that are higher up on the ship, the owner's cabin dining area is a little bit higher, wheelhouse, these all are affected by that. So, you know, the devil's in the details, of course, but now you have some quantitative feedback about what happens and how much it changes by when you look at different VCG values. So I really wanted to highlight what that workflow looks like and just how, you know, to be careful when you go through and calculating the motion RAO values with the ShipMo 3D toolset, and then make it easy to jump back and load those motion RAO files for making lots of comparisons. Thanks for watching.